Hello everyone, Matt here. In today's video we are going to start diving into coding exercises because I'm aware that a lot of you are trying to break into tech industry, or some of you are trying to switch and get a new job in another company, and whether we like it or not, coding exercises, algorithms and data structures are a very important part of that process. If you're new to the channel and you want to get better at full stack development and software engineering, don't forget to subscribe clicking the button below. Without further ado, let's get started. Today we are going to be tackling the problem of sum of two. According to Code Signal, this problem was asked a lot by Google, so let's get started. The problem is sum of two, and once the application loads, we will get the definition of the problem in here at the left. And yeah, let's read it and try to understand what we are meant to be doing, right? So the problem says you have two integers array a and b and an integer target value b. Determine whether there is a pair of numbers where one number is taken from a and the other from b that can be added together to get the sum of b. Return true if such a pair exists, otherwise return false. Okay, yeah, this kind of makes sense. Let's take a look at the examples. Basically, A will be an array of 1, 2, 3, and B will be another array with 10, 20, 30, and 40. And the value is 42. So the names are not the best actually, but we cannot change the signature probably. I will be solving this on JavaScript because I'm assuming most of you are more familiar with it. The parameters in here, A, B, and B, and the first two are arrays, so these arrays, and the third parameter is the value that we care, right? What we want to do is find the pair of values that can sum up to this target value, right? So we want to get 42. Is there any combination between these two arrays that can add up to 42? In this case, we can take a look and we say, okay, with 1, yeah, we don't see anyone, but we see that there is a 40 in here. So 40 plus 2, that is a pair, right? So 40 and 2 sum up to 42, and therefore the output should be true. We don't care about the indexes of the pairs or anything. We just care about whether there is a pair or not. So we return true or false. That's about it, right? And let's see, well, in here we have the limitations, and we can discuss that probably in another video because it is a little bit long to talk about how to read specifically this. But basically what this is saying is that we cannot solve this with exponential, with n squared. We cannot solve this with O of n squared. If you are not familiar with big O notation, I invite you to go and read it. I will leave a link below in the description so you can read a little bit about it. But the main idea is it is a way to measure the performance of an algorithm. And when we have quadratic time, this n squared is quadratic time, is how the algorithm performs when the data grows. So if we have a linear time and we can have a quadratic time, and then that will grow much, much faster. We try to be always below the square time because that grows super fast as the data grows. So basically these limitations are establishing that you shouldn't be solving this problem with n squared, right? And yeah, that's pretty much all the problem we have. And in this moment is where you would probably start asking some questions. If you are not sure about the problem, you can ask whether your function has to be able to work with empty arrays. What happens if one of the arrays is null or the other or both? What happens? Can you receive a null? Whatever. All the questions that you want to be clarified, this is the moment to ask. If you don't understand the definition of the problem, then ask all the questions that you need, and you can feel free to write some comments if you want. If you want to put some ideas together. I would like to have this example in here because I think that probably adds value to be able to see more clearly the parameters. So basically we will say this is the input of an example input, and our output should be true. Correct? Nice. Okay, so once we have this, We know, because of the limitations, that the solution shouldn't be n squared, but I always think it is a good approach to think how you will solve this in an easy way, even though it is not performant, or even not performant enough to solve the problem as it should be. So the easy way to solve this with n squared would be to simply iterate over one array, and for each element iterate over the other array. So what we will be doing is saying, okay, for the 1 I will check 1 plus 10, 1 plus 20, 1 plus 30, and 1 plus 40. If none of those add up to 42, then I will move to the next one, and then, oops, to the next one, let's change the color. I will move to the number 2, and then 2 plus 10, 2 plus 20, you get the idea, right? And when I get to 2 plus 40, I will say, oh, okay, I found a match, and then I return true. So that will be the easy implementation, and we can actually code it, because I think it is a nice idea to be able to code this, because if you don't get any better answer, if you cannot formulate a better solution than n squared, it is better to provide an n squared solution than not being able to do anything. So I challenge you to always be sure that you can write this easy solution, even though it is not performant, and then move on to a better solution. Once you are already confident in your skills, you can skip this step and just say to the people that is interviewing you, okay, I know I can solve this with n squared, but that will probably not be good enough, so I won't go that route unless you want me to. I would prefer to go this other route. So that is a very fine approach, and that shows that you understand the problem and that you can solve it in an easy way, but that is not performant enough, and therefore you are going to try another thing, right? That shows that you are thinking about the problem and the different solutions that you have, instead of just coding a map or whatever to try to solve it fast. So I encourage you to always take that extra step that shows that you know what you're talking about. So let's write pretty quickly what we will do. So we will do a for index A equals 0, while index A is less than a dot length. I will do index A plus plus, and then, well, yeah, I think we can skip this, but let's see. For index B equals 0, while index B, you can put y and j if you prefer. I like my variables to be a little bit more descriptive. And index B, I should have copied this. And basically we are iterating over the two arrays, and then if what? If A sub index A plus B sub index B is equals to value, then we return true. Otherwise, once we finish all the fors, we can return false. And I was saying that we may be able to actually skip this. You can leave them if you prefer. I usually, when it is an if with one-liner, I usually don't use brackets, but for the fors, I usually do it anyway. In this case, I think it is pretty clear enough what it is doing, and it can be a one-liner indented like this. So I think this solution should work. Let's give it a try. Once you have a solution that you think would work, you can click the Run Test button in here. Let's see what happens. Okay, if I didn't mess up anything, perfect. So we pass all the tests that are initial tests for the problem. Let's try what happens if we submit. I guess this should fail because of the constraints, and this solution is O(n squared), and we can actually write that. Okay, incorrect, see? In here it says it took some time to load, and in here it says test pause, but we only pass like 18/23 because execution time limit was exceeded on the other test, right? So we already knew about this. This means that we cannot solve this in O(n squared), and our solution is doing just that. It is nesting loops. This is the part that is doing the O(n squared), right? We are doing a for, and then inside of the for, we are doing another for the other data structure, right? So we cannot solve this way. It still is a valid solution, I think, just doesn't work for the requirements. So we can save this and put O of n squared. Let's put it in here so it doesn't mess with our comment on top. Let's think how we can improve this solution, right? One way that we can improve this is by actually pre-computing something, right? Usually you have two main ways at least to improve a solution. One is with an extra data structure that helps you to solve the problem in a faster way through some mapping or some operation. And then there are ways to solve them by actually doing a mathematical operation that can help out in the particular case that you're working on. And we will tackle different problems that will showcase this. But for this one in particular, let's think what we can do with this value that will help us avoid the double loop, right? What we are trying to do is find which pair can add up to this one. So that should give you an idea that we can work the other way around. Instead of adding up numbers trying to get to a number, we can probably pre-compute which numbers do we need to get to that number. And that is a subtraction. That is the complement of what we are looking for, right? So basically what we can do is pre-compute for one of the arrays what is the complement of each number. And that will be subtracting from the value what we have in each position. And then we can iterate over the other array and use some data structure that has better time for finding the value inside of the complement data structure that we created. So have a data structure with the complements that we can search through in a faster way instead of another loop, and get to the value to know if it exists or not. So that will be the main idea, and this is pretty common actually. This is a pretty common technique to solve these kind of problems. And the idea is to have a hash set or a map or a dictionary, you can call it the way you prefer, depending on the language that you work. And basically what a map or a dictionary or a hash set is basically it will have a key, and a value. And then whenever you do a search into a hash map, whenever we do a search, we will have O of 1. So basically the search is automatic because of how the hash sets work. I won't explain much more about this. We can talk about data structures in another video. Otherwise, this will be too long and I have problems explaining too many things at once. So basically, trust me, we can do search on O of 1, and that is the fastest that we can do in any other way, right? So we can search for the value 2, for example, in all the keys of here, and it will get to the value instantly. So we will know if the value 2 is present in here or not. In this example, we have 0, 1, and 12, and then this will say false. And if we have a 2, then it will return the value, right? So basically, a hash set usually in this kind of problems helps a lot because it allows you to remove one of the 4s that we were working before, right? And that is exactly what we are looking for. So let's see. In JavaScript, we don't have the dictionary we have in C#, but we can achieve the same functionality using an object. Objects work like a dictionary because they have keys and values. So let's do a for the second array, that will be B, and create a complement object. So let's create that object. Let complement lookup, and add an object to it. And then what we are going to do is add each complement from the second array. So in here, what we have to do is to put as the key of our map, we want to put the complement. That will be the value minus the value on B, right? The value on B. That will be the complement, and that is the key. It is very important that is the key because we are going to search by that value. So in here we will put B minus B sub index B. right? This is kind of annoying, but we don't actually care about the value of the map. We only care about the key in this particular scenario. So we don't really need the value. We can just put a true or whatever to say that it is present. Okay? So we fill our complement, and then we can move to use it, right? We just created our data structure. We have a wrong curly braces. Okay. We just created our complementary data structure, and now we have to use it. To do that, we are going to iterate over A, but it is very important that you notice that this is completely different from what we did before, right? In here, we are doing one loop, we finish it, we just go through all the items in B, and then we go through all the items in A. Before, we were doing nested loops, where we go through, for each item of A, we go through all the items of B, and then so on. So it is very, very different, okay? Let's remove all this. Perfect. So now we already have the lookup for the complement, and we have the value of A. And let's put an example in here so it shows on the screen. So basically what our map has right now would be 42 minus 10, that will be 32. Then it will have a 42 minus 20, that will be 22, then 12, and then 2. Okay, so this is what our map currently has. And what we need to do is, for each item of A, see if there is an entry on our complementary data structure. Okay, so that would be if A sub index A, that is the value that we are looking for. So we start with the complement lookup, and then we have a method in JavaScript that is hasOwnProperty. That is for objects, and it will check the list of keys to see if there is a key for the value that you are providing. So in this case, it will start with the 1, and it will search with the 1 if there is a key for that. And yeah, basically, if there is a key for that, then we will return true. And if we, oops, I'm missing. Okay, now it is complete. And if we go through all the items on the array A and we didn't find any match, then we just return false. And that will be pretty much it for this solution. And this solution should work perfectly fine. Let's give it a try. If I didn't mess up anything, it passes all our tests, and we can try to submit it. Let's give it a shot. Fingers crossed. And we have unlocked learning to crawl. Let's go. Let's go, baby. I think we can do something more. So basically, this code is pretty imperative, right? It works perfectly fine. It covers, it does what it needs to do, and it does it very fast, so it is very good, but it is pretty imperative. There are ways to better this, right? We can encapsulate some things, create methods, and try to make it more declarative, and we can also work with a structure that has already JavaScript instead of an object. That is a set. We can work with a set. The problem with a set is that it is not O of 1, but it is sublinear. So it is faster than linear, and that will make this work, but it is not as fast as this solution, okay? So I want you to take that in mind, but you will see that we can write this in a better way. So what we can do is we can create a set from B, and that will be a new set passing the array B, and then we can use the array methods from A to check whether this value is present on B. And to do that, we can just do return a.sum. Sum is a method for checking any, basically to see if any value on the array A, if any value on A fulfills a condition, okay? That is what sum will do. I will probably cover all the array methods from JavaScript in another video. Basically, what we will want to check if the complement of any element of A and the value target is present on the set from B. Okay, and to check that, we can use the set from B dot has, that is a method that will check if the set has a certain value, and we are looking for the complement from value and element. And that's it. And this is a two-line solution that will also work, but a little bit slower, okay? So this is the optimal solution, I think. I don't know if there is a better way to do this in terms of performance. I think not, but I could be wrong. So this is the optimal solution that I will present. And then there is the more declarative or more clean code solution, that is the one that you are seeing in here, that we will run now just to check that it passes everything. And yeah, let's run it and check if it works. Okay, it passes all the sample test, and we can try to submit it. Fingers crossed. And it is correct, okay? So that will be all. I hope you like this video. Don't forget to smash the like button below and leave a comment if you want me to keep doing more of these coding exercises and you feel this is helpful, because I could use some encouragement words in the comments. Thank you, and I will see you in the next video.